I welcome you for this presentation. In this presentation, we are going to discuss about a famous cryptographic hash function, that is MD5, Message Digest 5. This is the overview of this presentation, that is introduction to Message Digest, then Message Digest 5 overview, then structure of MD5, MD5 the implementation steps, then MD5 compression function, then strength of MD5, followed by summary of this presentation. This MD5 was designed by Ronald Rivers. Already you know who is Ronald Rivers, because we know a famous algorithm, that is a crypto system, that is RSA crypto system. We know the expansion for RSA is Rivers Shamir Edelman. The first R stands for Rivers, who designed the RSA. The same person only designed this MD5 also. The latest series of this MD5 includes the latest version is MD5. Before that we have MD2, then MD4. Likewise, message digest, various minor changes, delta improvement in each and every MD versions. Then this MD5 produces a 128-bit hash value. This is a hash algorithm. Here, you know what is a hash function. We are giving a variable size input to the hash function and it produces a fixed size value. And mainly it is used for authentication purposes and all. And in digital signatures also it is used. So it produces, this MD5 produces a 128-bit hash value, and this is the most widely used hash algorithm. After this algorithm only SHA was invented, and in recent times this MD5 is vulnerable to brute force as well as some cryptanalytic attacks. And this MD5 is specified in the internet standard, that is RFC 1321. And according to this RFC 1321, this MD5 was defined as MD5 message digest algorithm takes as input a message of arbitrary length and produces as output a 128-bit fingerprint or message digest of the input. So it is producing a message digest of size 128-bit, but the input to this message digest algorithm, that is this hash function, is of any size, but the output is of 128-bit. And this algorithm is intended for digital signature applications where a large file must be compressed in a secure manner before being encrypted with a private, that is secret key, under a public key crypto system such as RSA. Mainly, this is used in digital signature application. This is the definition given in RFC 1321 about this MD5. Let us see the detailed steps of this MD5 hash algorithm. So this is the overview of this MD5. Totally we are having 5 steps. Fifth step is just the output hash value only. First 4 steps are the processing steps. So first step what we are doing is we are padding the message so that its length is 448 mod 512 bits. In the block schematic it is very clear. Then what we are doing is we are appending a 64-bit length value to the message. First we have to pad the message so that the length becomes 448 mod 512. Then we have to append a 64-bit length value to the message. Then we have to initialize a 4-word, that is 128-bit MD buffer. The 4 words, that is the buffers, are A, B, C, D. They are named as A, B, C, D. Then we are processing the message in 16-word, that is 512-bit blocks. That is, here we are having 4 rounds of 16-bit operations on the message block and buffer. Totally we are having 4 rounds of 16-bit operations. Then we are adding the output to buffer input to form a new buffer value. Finally, we are outputting the hash value, that is the final buffer value, that is the message digest. So these are the steps involved in this MD5 cryptographic hash function. This is the block schematic or structure of the MD5. In the previous slide, we have seen the 5 steps. So first what we are doing is, here we have to pad it. In the message, we have to pad it. Then we have to append it. So the first step, the message size is of k bits. Then what we are doing, we are padding 1 to 512 bits, that is 448 mod 512. In that way we have to pad it, and while padding the first value is 1, the remaining all zeros. Then we have to append the message so that the message length becomes k mod 2 power 64. Then what we are doing is, then we are dividing the message into different blocks of size 512 bits. Then we are applying the initialization vector is there. Then we are performing some, we are giving the value to the hash function, the message, as well as using the initialization vector. The message size is of 512 bits, the initialization vector size is of 128 bits. Here we are performing some compression operation, and finally we are getting the message digest of size 128 bit. So this MD5 produces a message digest of size 128 bit, but the input to this message digest algorithm is of any length, arbitrary length, but the output it is producing is always 128 bit message digest. Let us see the steps one by one. First step is append padding bits. So how we are appending the padding bits to the message? That is, the input message is padded or extended so that its length in bits equals 448 mod 512, because we have to divide the message into 512 bits blocks. So here we are appending the message, that is, message is, we are appending some padding bits to the message so that the length becomes the multiple of 512 bits. And the padding is always performed even if the length of the message is already 448 mod 512. Whether the size is of 448 mod 512 means also we have to perform some appending process. Why means, the padding is performed as follows. A single 1 bit is appended to the message, and then 0 bits are appended so that the length in bits of the padded message becomes congruent to 448 mod 512. At least 1 bit and at most 512 bits are appended. So this is very, very important. So always we have to append the padding bits. Suppose it is of size 448 mod 512 means also we have to append the bits. But how many bits we are appending is, at least we have to append 1 bit, or we have to append at most 512 bits are appended. This is step 1, that is, we are appending the padding bits. Next is step 2. In this step 2, what we are doing is we are appending the length, because we need to know what is the size of the actual message. For that only we are appending the length in the second step. So a 64-bit representation of the length of the message is appended to the result of step 1. First step, we have to append padding bits, then we have to append length. If the length of the message is greater than 2 power 64, only the low order 64 bits will be used. The resulting message after padding with bits and with a B has a length that is an exact multiple of 512 bits. That only I already told you. We have to divide the full appended message into different 512 blocks. Then that is passed to the hash function. Then we are getting a 128 bit message digest. So the input message will have a length that is an exact multiple of 16, that is 32 bit. But 16 words, that is 32 bit. 16 words means of size 32 bit. Next, the third step is we have to initialize the message digest buffer. Here we are having 4 buffers, that is A, B, C, D. They are named as A, B, C, D. In SHA also we have seen some registers, buffers we have seen. Here also we are having the buffers. A 4-word buffer is used to compute the message digest, and each of the buffer is a 32-bit register. Here it is a 32-bit register, and these registers are initialized to the following values in hexadecimal, that is low order bytes first. So word A, the first A register, A buffer is initialized to 0, 1, 23, 45, 6, 7. So word B is initializes 8, 9, A, B, C, D, E, F. These are hexadecimal values. And the buffer C is initializes F, E, D, C, B, A, 9, 8. And buffer D is initialized as 7, 6, 5, 4, 3, 2, 1, 0. These are hexadecimal values that you have to keep it in mind. Then in the fourth step, what we are doing is the 4 functions will be defined such that Each function takes as input of the three 32-bit words and produces a 32-bit word output. The input to this also a 32-bit and it produces a word of 32-bit size only. So the four functions are named as f, g, h and I. And the f how we are calculating is f of x comma y comma z equal to x and y. So how we are writing is x and y are then not of x then and z. This way only we are writing this. That is f of x y z equal to xy, that is x and y, or not of negation of x and z. Likewise, we are calculating for all the functions, that is f, g, h and I. Each and everything here for h and I we are performing XOR operation. XOR operation is there. Here we are performing OR operations. So this way we are performing the computations, that is we are processing the message in 16 word blocks. And the last step is just we are outputting the message digest. So the detailed implementation step of fifth step is not given. Only 4 steps are the computation steps. Then here important thing is the MD5 compression function. That is here we are having 4 rounds and each round is performing a 16-bit operation. So each round has 16 bits of the form, that is A equal to, we already seen the buffers as A, B, C, D. So A equal to B plus A plus G of B comma C comma D plus X of K plus T of Y. Then shift operation S. How many value we are going to shift, that is represented here. So A, B, C, D refer to the 4 words of the buffer but used in varying permutations. Here this updates 1 word only of the buffer, and after the 16 words, 16 steps, each word is updated 4 times. Here a G of B, C, D is a different nonlinear function in each round of f of G, f, G, h and I. And T of I is a constant value derived from sine function. Normal sine value is there, no? So this T of I value is derived from the sine function. I will be posting you one sample document about MD5 because in 7th edition Williams-Stallings this MD5 is not included in the textbook. So I am giving you one material. You please go through that. There you are having all the detailed explanation of each and every values as well as the computation. So please go through that. So this is the schematic diagram of the compression function, and we have seen that we are having A, B, C, D, and here we are having G of one function we are computing, no? That is G of that. Then we are having this X of K and T of I, and this different operations, whatever we have seen there, that is represented in this pictorial representation. So this is the compression function using all the 4 buffers. This G is different from that capital F, G, H, I. So that you have to always note. So the strength of MD5 is this MD5 hash is dependent on all the message bits. Whatever the message we are having, it is depending on all the message bits, and drivers claims that security is good as can be. So whatever the security we needed from the cryptographic hash function, that is provided by the MD5 cryptographic hash function. Because while inventing that, because we are overcoming some of the disadvantages of the earlier versions. So at that time we proved that it is giving all the security aspects, but nowadays this MD5 is also vulnerable to some attacks. But earlier, while at the stage of implementation, it was claimed that security is as good as, but it is vulnerable to some attacks, and some of the persons, that is it is vulnerable to some attacks, like Burson in the year 1992 they attacked every 1 round using differential cryptanalysis, but they cannot be extended the cryptanalytic process. Then Boyer and Boschles in the year 93 they found a pseudo collision. Again it is also unable to extend. Then Dobert in 1916 created collisions or MD compression function, message digest compression function, but initial constants prevent the process of exploitation. But nowadays it is used in various applications, in digital signatures applications and all, but it is vulnerable to some attacks. So this MD5 is vulnerable to some attacks only after this MD5 the SHA was invented, and in SHA we have seen different versions. The latest version of SHA is SHA-3. In the next presentation we will be discussing about SHA-3. In this presentation we have discussed about introduction to message digest, then overview of MD5, then structure of MD5. Therefore we are having 5 steps, and 4 are the basic very important steps, and the 5th one is just we are outputting the message digest. And we have seen all the 4 important implementation steps of MD5. Then we have seen the MD5 compression function. Then we have discussed about the strength of MD5. Thank you.